Once again, you are most welcome to Anything Maths. This video is going to focus on past examination questions on the topic sets. Like the video and subscribe as well to the channel. Before I go through the questions, I want to make an important suggestion. If you are watching the video, I want you to pause, take a piece of paper and solve the question. Then after that, check your answer with the solution in the video. Doing this will help you with your understanding of the topic, and also you'll be preparing yourself for the examination. I hope you're going to take this suggestion on board. The first question we want to look at is write root 48 in the form of k root 3, where k is an integer. We'll be given an important information here, root 3. How are we going to use that information to our advantage? Just write 48. Three. Think of a square number. When you multiply by 3, that will give you 48. That is 16. We can write root 48 as root 16 times 3. Root 16 times root 3. If you watch the previous videos on sets, you know that this can be written in this format as well. And then root 16 is 4 times root 3. Eventually, you can write root 4 root 3. When we compare it with what we've been asked to find, we can see that now k is 4. The second question, write root 50 in the form of k root 2. We're going to use that same information to our advantage. 50 2, the square number is 25. So root 50 can be written straight away as root 25 times root 2, because we don't want to waste time. And then can 5 times root 2, 5 root 2. Compare it, k root 2, therefore k is 5. Not that difficult, isn't it? The next question, 5 root 27 in the form of k root 3. We still want to use that information of 3. So this is 3. The square number is 9. But remember, we have 5 root 27. The best way to deal with this is to put the root 7 in the bracket. So instead of root 27, we're going to write root 9 times root 3. And this becomes 3 times root 3. Expand, we're going to get 5 times 3 times root 3. And we work it out, you get 15 root 3. We want to compare k root 3. We know that k will be 15. Expand and simplify this expression. When we watch or look at this expression critically, it's quite obvious that this is a difference of two squares. And that is the reason why I took my time to explain it to you in the previous video, so that you don't have to go through expanding this, because it's going to waste your time in the examination room. We can simply write 2 minus root 3 all squared. We're going to have 4 minus 3, and the answer is 1. The next question is, we're supposed to square 3 plus root 5 all squared in the form of a plus b root 5. That's exactly what we're going to do. So we have 3 plus root 5 times 3 plus root 5. Now when we expand, we're going to get 9 plus 3 root 5 plus 3 root 5 plus 5 all squared. And we're going to get 9 plus 6 root 5 plus 5. When you simplify, we're going to get 14 plus 6 root 5. So we can see that it's in the form of what? A plus root 5, where A is 14, B is 6. Expand and simplify. This is not a difference of two squares, because this place is 2 and we have 1 here. Be careful, because the examiners are very clever people. They want to trip you up, so you have to be on top of your game. What we're going to do a normal expansion. So 2 times 1 is going to be 2. 2 times negative root 5 is going to be 2. Negative 2 root 5. And the next one will be root 5. And we're going to have root 5 all squared. Let's work things out. We're going to have 2 minus root 5 minus 5. We have minus root 5 because negative root 5 plus root 5. And the answer becomes negative 3 minus root 5. And that is the answer. Be careful when you are dealing with the negatives. Don't rush. We have 3 minus 2 all into bracket square. I want to teach you a formula. Maybe you already know it, but for some of you who don't know it, it helps in the exams to save some time. Imagine you have x plus y all squared. Instead of doing the long expansion, what you can do, you square the first and you multiply 2 by what you've been given, then you square the last. Y squared. Let's see how it works. It's very, very, very easy. Now we have 3 root 2 all squared. So this time 3 is x. So 3 squared plus 2 times 3 minus root 2 plus negative root 2 all squared. We're going to have 9 minus 6 root 2 plus 2. Then when we work it out, we're going to get 11 minus 6 root 2. And we can see it's in the form of what we've been asked. We have a plus b root 2. This means a is 11 and b is minus 6. If you're finding that difficult, you can do the normal expansion. It means you have to do it this way. Root 2 times 3 root 2. Then you expand. You get the same answer. This particular question can be solved using many different methods. You can solve it as a difference of two squares, or you can do the expansion. I'm going to not solve it as a difference of two squares because it's going to confuse some of you. I'm going to use the expansion method instead. Let me remind you of what I taught you a short while ago. When we expand, we're going to get x squared plus 2xy plus y squared. We're going to use this. The first bracket will give us 4 plus 2 times 2 root 3 plus root 3 all squared minus, let's put a bracket here because of the minus here, okay? And we're going to get 4 minus 2 times 2 root 3 and then plus root 3 minus root 3 all squared. We want to simplify. We're going to have 4 plus 4 root 3 plus 3 into bracket 4 minus 4 root 3 plus 3 and 7 plus root 3 minus 7 minus 4 root 3. When we expand, we're going to have 7 plus 4 root 3 minus 7 plus 4 root 3. The 7 will cancel. This 7 will cancel this 7. And we're going to be left with 8 root 3. So that is the answer. We could have solved this as difference of two squares as well. So you can try that method and see which one you feel comfortable with. Rationalize the denominator 6 over root 3. So we don't want the root 3 to be the denominator. We want it to go to the top. We use the trick, so it's going to be 6 root 3. Instead of multiplying by 1, we multiply it by 3 over 3, which is the same as 1. We multiply the numerator with 6 root 3, and the denominator will be 3. These 3 will cancel this 6 over here. 2. This 3 will never cancel the 3 under the square root sign. The answer will be 2 root 3 over 1, which is the same as 2 root 3. The next question, rationalize x over root x. X over root x. Multiply by 1. We do that, 3x over root x. Multiply the numerator, we get x, root x, all over x. Then this x, we cancel that x, we're going to get root x over 1, the same as root x. Rationalize the denominator, 1 plus root 5 over root 2. Let's put a bracket around this. Root 5 all over root 5. And we multiply it with root 2 over root 2. Expand the numerator. When we expand, we're going to get root 2 times root 2 times root 5 all over 2. And we're going to get, this is plus, we get root 2 plus root 10 all over 2. And there's nothing more we can do, so the answer is root 2 plus root 10 all over 2. You don't have to stress yourself. This is the answer. Rationalize 3 plus root 6 over root 3. So we have 3 plus root 6 all over root 3 times root 3 over root 3. When we expand, we're going to have 3 root 3 plus root 6 times root 3 all over root 3, because it's going to be 3, because this one will be root squared. When we expand, we're going to get 3 root 3 plus root 18 all over 3. Remember, 18 can be written as 9 times 2. So we're going to have 3 root 3 plus 9 times 2 all over 3. Let me go slowly. So we have 3 root 3 plus root 9 times root 2 all over 3. And the next step will be 3 root 3 plus root 9 will be 3 times root 2 is going to be 3 root 2 all over 3. Now we can factorize 3 out. So we have root 3 plus 2 root 2 all over 3. And the beauty is these 3 then cancel these 3, and then we get root 3 plus root 2. Doesn't really matter which comes first. Doesn't really matter. When you see this sort of question, don't panic. They are not very difficult. When we look closely, we can see that the top is just a difference of 2 squares. So it becomes much easier. So always look out for it. We can write the whole expression using that idea as 4 squared minus into bracket 2 root 3 all squared all over root 11. It becomes much easier. If you square these, we will get 16. If you square 2 root 3, 2 becomes 4 times 3, you get 4 times 3 all over root 11. And work things out, I get 16 minus 12 all root 11. And it's going to be 4 root 11. We are not done yet. We're supposed to simplify fully. We don't want this root 11 to be here. This is a tricky question. So we want to rationalize, though we've not been told directly to do so. Because of the word simplify, we want to do that. So it's going to be 4 root 11 times root 11 all over root 11. We're going to have 4 root 11 all over 11. And that is the answer. This sort of question is interesting because we're supposed to write this expression in a form of 4 minus root 3. It means when we simplify, we do the rationalization, we have to get 4 minus root 3. Okay, so let's see. Take your time. Don't force yourself to get 4 minus 3. The answer should come by itself if we follow all the principles. So let's go through the question. We have 5, 2 root 3, put a bracket around it. We have 2 plus root 3. There's no rationalization mentioned, but you have to. It's a show that. So we use the idea, this is plus, so it's going to be minus root 3 and minus root 3 as well. If you multiply expand the numerator, we're going to get 10. 5 by 2 is 10, and we're going to have 5 root 3. If you multiply, you're going to get 4 root 3, and this will give us 6. All the difference of 2 squares, so 2 squared minus root 3 all squared. Let's simplify. 10 minus 6 will give us 4. And negative 5 root 3 plus 4 root 3 will give us negative root 3. We're going to have 4 minus 3. 4 minus root 3 all over 1. And we're going to get 4 root 3. And that's what you're supposed to have, isn't it? So we've been able to answer that question. Do not panic if you don't get it. Try and have a look at it, but don't waste your time, okay? Because you're going to be given a method mark as well. It says show that 1 over root 2 plus root 2 can be written as root 2 over 3. This is a bit quite difficult when you look at it, but it is not. So what we have to do, we have to simplify the denominator first. using the idea of adding fractions. So we're going to write 1 over root 2 plus root 2 over 1. And what we're going to do, we multiply here by root 2 and divide by root 2. Okay, this is not rationalization. We're just doing addition of fractions. So the whole thing now becomes 1 over root 2 plus 4 over root 2. And we can add the 12, which is 5 over, no, I've made a mistake here. You can see it should be 4 instead of, we're going to have 2 here. So the whole thing becomes 1 plus 2 is 3. And we're going to have root 2. Okay, so you need to be very careful. You can see when I don't pay much particular attention, I'm making mistakes. Okay, so you have to be very careful when you are working these sort of question. Now, the whole thing can be written as 1 all over 3 over root 2, which is the same as 1 divided by 3 root 2. And it's the same as 1 over 1, change and flip, isn't it? All over 3. Multiply the top, you're going to get root 2 all over 3. You got the answer. So please don't rush. Take your time so that you get the answers correct. Now simplify fully. So once you've written this fully, you need to be very careful. It means you can simplify partially. This is just a difference of 2 squares. So we can write this as root a all squared minus root b all squared. Root a squared is a, and root b squared is b. We are done. If you want to expand, it would have been very, very tedious. So always spot for these difference of 2 squares. Save us time. We have simplified fully. So be careful when they put this word here fully. We're going to use the formula x plus y all squared is the same as x squared plus 2xy plus y squared, so that we can really work faster. We have 2a plus root b all squared. Our x is 2a, so 2a all squared plus 2 times 2a root b plus root b all squared. We're going to have 4a squared plus 4a root b plus b squared plus b, not b squared. Now, when you look at these, we can factorize 4a out. So that is why they're asking you to do it fully. We have 4a, get a plus root b plus b. And I prefer writing it this way, b plus 4a into bracket a plus root b Nice and easy. This brings an end to this video. If you found it useful, and I'm really hopeful you do, like the video and also subscribe to the channel.